stretch. Okay, so we have a really nice and fun, we hope, set of lightning talks. And then we'll do some logistics and thank yous at the end, and then you will all be free to go. But first, let's get started with our set of lightning talks, and we're going to welcome Margaux, Faure, and Juliette Hueber to present the PerVisum project, IIIF, and scientific publishing.
Good morning. Margaux, Faure, and I are working at the French National Institute of Art History, and we're going to present PerVisum, a 2-year project funded by the National Fund for Open Science. So in this presentation, we are going to talk about writing and publishing. The PerVisum project explores editorial format that center academic demonstration on images. The main goal of PerVisum is to provide an innovative framework and methodology for the writing and the publication of visual scientific articles. The project includes several objectives, but the one we are focusing on today, the prototype of the IIIF manifest generation tool. This tool is designed to fit into the scientific publishing workflow, and it supports the IIIF format, both to read and create a IIIF manifest.
So we are developing a prototype based on open source technologies that allows the user to compose an editorial manifest. The tool offers 2 types of outputs, an enriched portfolio that can be added to an article, or a more exploratory format where IIIF annotation serves as containers for the scientific narrative. So this is this second format that we will present today. So now on screen you can see a result of a scientific demonstration written by one of our colleagues. And you have the title of the article at the top of the screen. And so the display text corresponds to a set of IIIF annotations that have been sequenced and organized. So you can see that the areas of interest on the image are highlighted while remaining in their original context, thanks to IIIF. And what is interesting is that you can navigate either through the image or the text. So this scientific demonstration was built with the PerVisum tool. So we're going to see how it was created. And so we approached it by breaking down the necessary features to translate the scientific writing process into a web application. Next video. The applications allows you to create an editorial unit and add images to it. So you can create a corpus by adding a manifest link. And the application loads all the images from it. You can select the one you want to use. And you also have access to a list of manifests, allowing you to complete your selection at any time without needing to re-enter your manifest link. So once validated, the images are added to the corpus, and you can edit the metadata, add new ones, or retrieve metadata from the original manifest. So that's the corpus part. These images can be organized into subsections, which you create. So these sections can be interpreted as several portfolios or as the major section of the article we are currently drafting. The idea here is to begin shaping the structure for your demonstration. The real space environment is the writing space, sorry, is this one. So you can find all the sections you have created, so the 4 parts here, and all the annotation created within each sequence. So we can select a section, so that's the last one, and you see all the images placed there, and you can select annotation, so edit it, but you can also create a new one. So this is the demonstration of a new annotation. And you will see just after that you can reorder the annotation, so the user can control the narrative flow of their discourse. So now, how is it structured in IIIF? So the application generates a manifest for each editorial unit. Each selected image is inserted into a canvas, and we use the structure section to store the writing work within the IIIF ranges. Why this? It's because it lets us organize the content into clearly titled sections, and that fits the logic of the scientific writing. And another interesting thing is that it lets us use an image multiple times, but each time with different annotations. Yeah, so to render this, the viewer interprets the manifest by reading from the structure section. So for each range, it displays the annotation in the order defined by the author. So now here you can see that the manifest, the editorial manifest, is built dynamically based on each other, based on the user's action across the different interfaces.
So we expect to make the code open source with the first stable version of the tool likely around September. And speaking of next steps, we are working on developing and implementing editorial output in various formats like HTML, EPUB, and PDFs. We would like to continue working on creating a seamless application experience that eliminates interruption and aligns with the user's thought and writing flow. And we would also like to explore the potential applications of AI to identify relevant regions, to annotate and to suggest annotations. And we are trying to provide a free hosted access to the application as a SaaS solution. So if you are interested in trying PerVisum, feel free to contact us. Thank you.
Richel, Cuyler, and Meredith Steinfels presenting creating partnerships for cross-collection searches.
Hello, I'm Meredith Steinfels. I am the Assistant Director of Digital Platforms, Media, and Archives at the Hood Museum of Art, Dartmouth.
Hi, I'm Richel Cuyler. I am Technical Developer at the Hood Museum of Art and also part of the Digital Libraries Technologies Group at Dartmouth Libraries.
All right, and we are here to talk about our journey in establishing interdepartmental use of IIIF for cross-collection presentation and or discovery between a museum and a library, or our attempts to. So from the museum perspective, we are a small team. We're relatively new. We've only been around since about 2018. It just started with me, then it grew to 2 people, and now we're at 5 people. We get our IIIF JSON from our DAMs using the vendor-created infrastructure. It's good, it's not great, but it's usable. And we also use exhibit.so because we do a lot of close-looking journeys for our work.
So from the library perspective, the library has a larger technical team with a long history and positive track record in projects and maintenance. They're potentially, they are potentially seeking partnerships and can offer more resources as a larger part of the institution. They're currently implementing IIIF into a homegrown system, which has created and presented its own challenges. They also have access to Exhibit for student and faculty use. Right now, the challenge is really figuring out how to implement in a homegrown system versus a vended
option. So I don't like to start a project unless I have a problem statement or a few. And so my problem statements are this, which are a library and museum care for cultural heritage collections, some of which come from the same origin in siloed digital systems. The library and the museum want a way to easily present related objects in our collections, but we don't really have the capacity, nor do we have a need for just like a one system to search them all model. Like we need to keep governance sort of separate.
So in order to sort of get to our goal of this collaborative effort, we have some considerations and some needs. So we have to first recognize that there are differences in work style and approach between the libraries and the museum. So the museum, we're very experimental because we're a small, scrappy team, versus the library, which is much more analytical and methodical. They tend to build a case first and then implement. We have differences in software and computing power, so the relative complexity of the library systems. There are over 200 employees and they operate over 50 systems versus the museum, which is about 50 employees, and we have about 3 collections-based systems that we use. So difference in scale, definitely, and computing power. And then we also have to consider our audience and needs. So who are we doing this for and why? And thinking through different approaches for our tech infrastructure, scale, and audiences will sort of help us how to get to our goal.
And then we also, again, back to staffing and labor, a fleet of developers and 0 to 30% of Richel's time. I have about 70 to 100% of Richel's time. And then we also have a mutual learning fellow for cultural heritage, technology, and innovation. Budget, we live in the United States, it's 2025, we're at a university, that's not happening. So, yeah. Sorry to make everybody uncomfortable with that one.
The reality of things. And so another set of considerations of content and use. So for our metadata across both the museum and the library, where can we find standards that work between the both of us so it makes sense in a manifest and a viewer? And then also for research, how do we make something that's easy for users to learn about and create related cultural heritage between the two of us. So we have collections that have related objects and relationships. And so with differences in resourcing and also standards like headers and conventions, we need to figure out how to offer something that meets all of these considerations and needs. So, is the solution IIIF? Yes, it is. Actually, and before we can collaborate on a more enhanced and built system that we actually create ourselves, we've been using IIIF sort of in a manual sense where students will do their own research and then put something inside of a IIIF viewer or presentation. So we need to think about the key to cross-collection discovery in the future. So we believe that IIIF's model offers us the most flexible and lightweight approach. Of course, it's free, well-maintained, scalable, widely used. Maintain control of our own data and actively work or collaborate on reasonable crosswalks that make our collections make sense. If IIIF can be used separately or it can be used in collaboration, that makes it more flexible for us, and we aren't forcing a fit. So these are, things that have been done before that we can pull from.
So our approach, we've found a solution, and how do we move from the theoretical to the actual implementation? And first of all, just opening an open line of communication, and also just gauging the understanding of your partner. Like IIIF is a lot, it's a lot of things, it can be a lot of things to many people, and it can be like this full-scale implementation with a jillion APIs, or it can be something really, really lightweight that you grab either from the cookbook or from some of the free tools that all of you people much smarter than me have already built. If you have access to test or sandbox environments, you can set examples for use, again, build use cases, and just show the different ways in which you can incorporate IIIF into your work. And financial sustainability, IIIF is free, thank you for that. And then how do we learn from the work of one another? Well, with the museum's quick adoption, the library has been able to see it in use and that it is in demand, that it works, and that people are happy with it. But conversely, we adopted it so quickly, the museum, that we do have issues that need solved. And when the library has a more methodical and careful approach, we can sort of see what they're doing, and then maybe look towards a V2 for ourselves.
And so, revision and iteration, definitely something that's a part of every tech project. So how can we keep improving? We'll continue to share our case study with the IIIF community, which is you all, and are in support of others. We'll check in regularly in meetings with library staff to sort of evaluate and brainstorm. We will review use and analytics, and we have a revision. We will have a revision system based on use and feedback within the Dartmouth community, staff, stakeholders, changes and updates to IIIF standards. When does it make sense to change and when to hold off? Where do those changes occur? Community use of IIIF in similar situations to ours. IIIF is robust, evolving, and well supported. Museum versus library tech stack changes. For example, if our vended solution changes or if the homegrown solution needs changing. Continued muse tech conversations, so our colleagues at other institutions who are working through some of these same issues. And then the numbers, and we'll specifically review in a way that constructs an appropriate narrative. And this is still an area that's of relative weakness for the museum, but we have our library colleagues to lean on who are also already doing this well.
So, in summary, right now we're in the frequent check-in phase. The library's infrastructural approach just means it's just taking a little bit longer from them, whereas we probably have to do a lot of revising on something we've already implemented. We're hoping for the next phase, which hopefully will be a proof of concept, because then the library has a sort of a deadline internally of July. And so far, I think that this has been successful, even though we haven't had like this full implementation. Even a library and a museum agreeing fully on a system and agreeing on the governance of a system, I think is like a huge step, and I think it's really fabulous. And I hope to present on an implemented version of this at a future IIIF. Thank you.
We're going to welcome Erin and Sara, professionals developing in the community to develop software for universal use.
Thank you. It's lovely to have the opportunity to present today. Sara and I are representing the Universal Steering Group to talk about the steps we've taken to ensure that the UV remains a well-maintained, community-driven project with an active network of trusted committers.
So the UV started life in 2012 as the welcome player created by Digirati, which was then developed into a IIIF viewer on behalf of the British Library. So although a successful project, there needed to be a way to keep the UV sustainable and our users happy. So setting up the Open Collective attracted international sponsors, and then following the 2019 UV conference, the steering group was set up. And this provided transparency and structured decision making. So the steering group members pay monthly or yearly membership fees into the Open Collective, and we're happy to answer any questions about the Open Collective later on. However, early development still relied heavily on individuals or isolated procurements, lacking long-term sustainability.
So it became clear that we had to engage the community to be able to support and develop the UV, but there are a number of barriers to contribution. So university is not really something you can just get stuck into. Those getting started with the UV had to struggle with a complex, under-resourced code base. There was a lack of documentation, and there was no documented policies or procedures. And this meant that we had a limited number of developers that really understood the UV's architecture well enough to implement significant changes, and there was a dependency on individual goodwill. And ultimately this resulted in scattered development efforts, so without coordination, features were developed in silos, and this led to UI and code complexity. So while we needed the community to develop, there needed to be structure to ensure there was direction to those developments.
So we decided the community project sprints and community project and sprints were the answer to this problem. So we'd run project sprints before, but these were community funded rather than community developed. So our first true community sprint was in October 2024. And so far, we've run 4 successful projects under this model. So running agile projects within a single organisation can be challenging enough. So coordinating those that involved multiple organisations across the globe requires thoughtful planning and attention to practical details. So we manage all community and institutional-led developments using public GitHub project boards, and we use both the UV and the IIIF Slack channels to promote calls for participation. So we needed a centralised space to capture key sprint information such as goals, MVP and participant details. And Miro provided an ideal solution for this due to its ease of access and shareability. The feedback from sprint retrospectives showed that we needed project-specific GitHub boards to make backlogs easier. We also created a dedicated community sprint channel on Slack, which is the main centre of communication during sprints, allowing open access to discussions captured outside of outside of daily scrums. And I think I went too far on that one, so that's that one, and I'll go to slide 6, apologies. So we hold the usual agile ceremonies and have fostered a culture of self-management and shared leadership. So as our project teams often include 10 or more people from 6 to 8 international institutions, collaboration and clear communication in planning and in our daily scrums has been the cornerstone of our success here. The strong commitment and generosity of the community in offering their time, energy and resources to these projects, as well as feedback from our stakeholders, this will ensure the universal viewer continues to thrive.
So this change has fundamentally reshaped how we work. It's placed decision-making and responsibility into the hands of the wider community rather than a small group of funders. It's allowed us to decentralise both development and non-development tasks, and it's lowered the barriers to entry for contributors, creating a more welcoming contributor environment. Holding open sprints with regular stand-ups has meant that community members can actively participate in a real-time developer environment, and we've seen a real drop in the number of reported issues, thanks to stronger peer support for new and existing developers. And this broader community involvement also frees up the steering group to focus on strategic coordination, long-term planning and road mapping. But perhaps one of the most important outcomes of running these community projects has been the shift from a model driven by passive sponsorship to one powered by a broader base of active community stakeholders. So we've learnt an awful lot during our time running these, and some of the assumptions we initially made were probably incorrect. So we've learnt that the community and its associated institutions are willing to contribute time and effort, and we've increased our sprint duration and frequency as a result. We've also seen that a flexible approach to time commitment works really well, and it's possible to manage community and institutional priorities effectively for mutual benefit. We've also seen the importance of good comms, both to increase sprint participation and also for the visibility of the work that we're doing, and we're making plans to improve our messaging by identifying the most effective communication channels. So ensuring consistent participation in these sprints and in governance remains an ongoing effort. The way we view the sprints has evolved over time, and we're now seeing them as a bit of a blanket to wrap around the community, which I know is a little bit cheesy, but bear with me. And it just means that those who wish to work to improve the UV can do so with the full support of the community. So that's the sort of framework and the foundations behind all this, but you know, what do we actually deliver? Because that's obviously the point of all this. And this programme of community sprints has resulted in a huge amount of improvements for the UV. We've delivered in key areas such as accessibility, mobile and developer experience, and these have been really well received by the community, not least because these regular community sprints have driven releases, and we're now on, I think, the second release coming up so far this year.
So none of this would have been possible without all the institutions who have contributed time and resources to the project. So a big thank you to all those who are part of the community and the steering group. We want to continue to improve on what we've built so far. As UVCon 2019 was a milestone that brought many improvements to the UV community, without which we wouldn't be here where we are now, we're planning UVCon 2025, bit of a gap, but you know, in early November we should have UVCon 2025, where we will showcase recent changes, we'll consult with stakeholders, work on our roadmap and invite the community to participate in workshops. And we're also always looking for ways to make our community events more inclusive, So if there is something holding you back from participating, please let us know. So until then, please join the discussion on Slack and keep your eye out for information regarding future projects. We do have Sprint 2 of our DevX Sprint starting next Tuesday, 10th of June. If you would like to join, please come to our Slack channel, the Community Sprint channel. And this has been a very high-level overview of what we achieved and what we did in 7 minutes. So please come and talk to us after this if you want to know more about anything we're doing, or contact us on these email addresses. So thank you very much.
Thank you very much.
Okay, up next is Claudio to present managing IIIF annotations in a digital library environment.
Okay, thank you very much. Good afternoon. Okay. Good afternoon. In the next few minutes, I would like to share with you a new step forward in the journey we at For Science have been on with IIIF in the last years, since 2017. In that year, we released the first IIIF integration for DSpace, in particular for our extension of DSpace for CRIS and GLAM domains. In 2021, we released the IIIF integration for DSpace 7 to the whole DSpace community. In 2023, we joined the IIIF consortium, becoming associate member in order to give further support to the consortium. And now, in 2025, we integrated IIIF annotations management in DSpace CRIS and DSpace GLAM. And in this way, we created a new workflow to integrate IIIF annotation with all the whole knowledge base included in the digital library, produced by metadata, full text, and entities according to the implemented data model. The starting point was the Mirador plugin for annotating images. This plugin allows you to create annotations by means of rectangles, oval, polygons, adding text description, but by default, annotations are stored in the browser local storage. And so when you close the browser and remove the cache, the annotation is not preserved anymore. So what we have done to overcome this issue, we create a workflow within DSpace by which the authorized users can create annotation with Mirador, and such annotation are saved as DSpace items. In this way, annotations can be related with all the other objects that are created in the digital libraries, publications, events, people, and so on. And in this way, annotation can also be searched together with all the other objects included in the digital library. So we have a full integration between annotation and the rest of the knowledge base included in the digital library. Here, starting from an annotated image with Mirador, we see that the record, the annotation item is created where the annotation is saved as an abstract, and you can enrich this annotation with adding the subject or whatever other metadata you would like to add. And you can see that the annotation is related with person, with a place, with two events, and so on. And as a DSpace item, the annotation can be provided with a persistent identifier, so which is fundamental for preserving annotation in the long term. You can use the person identifier already implemented in the space, such as the handle or the DOI, but in the future, since in the roadmap we have also the implementation of the ARC person identifier, you will be able to use also this kind of persistent identifier. And moreover, as a DSpace object, you can expose the annotation by means of interoperability protocols like the OIPMH or with a Sparkle endpoint, and you can also export them in archival information package format according, for example, to the METS standard. And here you have an example of a search in which searching for a string, in this case the flagellation, which is a painting related to Italian Renaissance, you can see not only that you find the painting and the events related to the painting, but also the web annotations related to the painting. Moreover, since you can manage the annotation authorization according to the granularity provided by the space, you can allow authorized users to create personal annotation that are not visible by front-end users. In this case, for example, a teacher or a researcher can use the digital library to create annotation for her or his students, or a researcher can annotate the images for her or his own research, not affecting the front-end experience of the users of the digital library. In this way, the digital library moves more and more to a teaching and research tool. So what we have achieved implementing this kind of workflow, we have transformed annotation in real digital objects that exist independently in the repository, and each annotation can have its own metadata and permissions. They are totally searchable together with all the other objects included in the digital library, and they can be connected with all the other entities, obviously according to the implemented data model. And so the digital library administrators are able to create new connections within annotations and all the other entities, and they can so reveal hidden relationship between various materials. So if, as we have seen in these days, and we will see also tomorrow in the workshop, IIIF integration creates a richer user experience for cultural heritage collections, we think that connecting annotation with the digital library knowledge base unlocks new research possibilities. And in order to create more and more content relationship, pushing digital libraries and digital heritage management to a next level. So if you want to see some hands-on and some demo about this implementation, look for me at the sponsored desktop or all around. And thank you very much.
Next is Matthew Yang to present SEAFILM, Reframing Access to Southeast Asian Cinema with IIIF.
Hello. Hi, I'm Matt Yang from Singapore, and also the graduate intern at the Getty at Los Angeles, and also a very grateful recipient of the IIIF Travel Scholarship. So first, a big thank you to the Scholarship Committee for your vote of confidence. And as someone completely, honestly new to IIIF, but also someone who works extensively with time-based media, I'm really interested to explore how IIIF can enhance access to moving image collections, and today I'll be speaking specifically on how it can do so with Southeast Asian cinema. So for those who are unfamiliar, Southeast Asia is home to over 680 million people across 11 countries with incredible linguistic, cultural, and political diversity. And it makes up ASEAN, the regional bloc like the European Union, that facilitates economic and political collaboration. But in the sphere of cultural heritage, shared infrastructure remains limited. And this regional diversity is a strength, but also it presents unique challenges for coordinated cultural preservation. And in the mid-20th century, countries like the Philippines, Indonesia, Malaysia, Singapore, and Cambodia developed thriving film studio systems, often state-supported and or regionally networked. These film studios produce films that address post-colonial identity, nationalism, and modernity, marking a golden age of artistic and commercial success in the region. The 1950s to 70s marked the peak of film production in Southeast Asia, with countries like the Philippines and Indonesia producing hundreds of films each year. These films were critical voices for their nations. However, many of these films are now lost due to three major threats. The first is climate and environmental degradation. Southeast Asia's heat and humidity is the ultimate nemesis for film and magnetic materials like videotape. The second, censorship and political interference. Numerous films have been banned, suppressed, or destroyed during authoritarian regimes. And the third is simply the lack of expertise. There's a shortage of trained archivists, cultural heritage developers, and technicians due to limited training opportunities. But yet, archives across the region are working tirelessly to address this. But yet, what you see here is the reality of fragmented stewardship, with each archive using different systems, formats, and standards. This makes cross-border discovery, scholarship, and collaboration difficult unless we build systems that can connect them. And so this is where I feel IIIF can come in, where it will allow distributed archives to publish, share, and compare time-based media using a common standard. And this enables deep linking, multilingual metadata, timestamped annotation, and federated access across institutions without requiring centralized ownership. And I imagine and would like to build a shared portal for Southeast Asian cinema, where archives across the region can contribute their collections through a common standard, allowing users to explore content without needing to know which institution holds it. And this platform will act as a virtual commons, unlocking discovery, teaching, and collaboration across borders. So here's what I think the platform could offer. So the first is a side-by-side film comparison, which will be helpful to assess the condition and versioning of film prints. Second, clip export with IIIF citations, great for students and researchers. Third, time-based annotation commentary for all tagging. Sorry, I'm getting ahead of myself. Fourth, linked resources, connecting films to posters, scripts, and related materials. As for the use cases, imagine a student searches for depictions of war memory in Vietnamese cinema and annotates scenes for a paper. Or a curator that discovers lost Cambodian films from archives and contributes metadata. Or perhaps a writer that compares representations of colonial architecture across Singaporean, Indonesian or Malaysian films using frame level comparison. So to preserve and share Southeast Asia's cinematic legacy, we need tools that celebrate its diversity collaboratively. And IIIF offers a practical, collaborative path forward to build a platform where borders don't limit access, where lost stories can be found, compared, and remembered all together. So thank you all for your time, and I welcome all of your questions, advice, and collaboration.
You can't have it hanging.
Oh, sorry.
Okay, it's that time again. Tristan Roddis is here to do fun with IIIF.
Hello, is this thing on? Can you hear me? My name is Dr. Tristan Roddis. I come from a small research institution named Cognitive Applications on the south coast of the UK, and I would like to present to you some of my research findings today. Next slide, please. Next slide, please. Thank you. In this talk, I will be going through the methodology. I will also be talking about the classification of fun, my preliminary findings, and finally, some tentative conclusions. First of all, the methodology. I started my interest in fun in 2016. And from that initial data set of a mere 9 projects, it has now swelled to over 42 projects. This is a picture of the first slide of the first presentation. This is a picture of some of the data. We have analysed this vast data set using cutting-edge techniques. In particular, classifying it by API use, by year of creation, by spatio-temporal dimensionality, and of course, by function. As any serious researcher of fun knows, the best way to start is by examining which versions of the API are used. As you can imagine, the image API dominates, followed by the presentation API and a single sole entry for the content search API. From this, we can draw various conclusions. The first of all is that authorization is no fun, nor is change discovery, and of course, neither is content state. I ask you, who will take up this challenge? Here is the only entry that uses content search. This is a primary source ransom note generator by my ex-colleague Alpanis Sotirius. And in conclusion, we need more examples of more APIs. The second thing we did was to examine the number of fun entries created over the years since our data set began. Now, some people may look at this graph and believe that fun will be almost entirely eradicated by the year 2026. However, I believe there is an alternative explanation and analysis. If we look at the cumulative fun per year, we see a very different picture. And indeed, if we extrapolate this to the year 2100, we find over 292 fun projects will be produced. This equates to 1 IIIF fun project per 38 million inhabitants, even accounting for population growth, which is a considerable improvement on the current ratio of 1 for every 192 million. In conclusion, things are looking up. The next sort of analysis we did was to check the spatio-temporal dimensionality using, of course, a right-handed model with Z up and Y forward. In this, we found that 2-dimensional things dominate the XY plane, and only a few entries for the third dimension or for the passage of time. From this, we have found, again, there are no entries with only one axis. Who will take up this challenge? There's a poor showing for Z and a poor showing for T. And from this, I asked myself the research question, can fun only exist in 2 dimensions? To answer this, I dug into the data. Here is an example of something that involves T, where T equals time. Time is passing, and the picture is getting closer and closer. Here is another version with time, and also audio. I can't work out how to turn this volume down. I'll just have to shout. This is using an API to analyse song lyrics in real time and pull out images that correspond to them. What a racket. Next up, I looked at the third dimension. Here we are in space, in 3 dimensions, looking at some old trade cards from the Boston Public Library. You can zoom around them and look at the backs of them as well. In space again, this time looking at an n-dimensional map of the similarities between artworks and objects in the Victoria and Albert Museum and the Science Museum, and zooming around looking at similar things. In short, I found there was enough data to support the conclusion that fun does not only exist in 2 dimensions. Although, this is your last warning, 3D working group. If I do not receive any more submissions by next year, I will have to revisit my conclusion. Finally, I decided to classify all of the fun. This took several months. Here is an example of a utility, the utility being that of creating guided storytelling. Here is another example. Many people have come to the same conclusion that producing a guided exploration and allowing other people to create those explorations is a useful thing. My conclusion from this is that guided storytelling is genuinely useful. It is also fun. And to that I say, yay. Then let's look at the next classification, that is of beauty. How can we reveal the intrinsic beauty of all of these IIIF things? Here's an example from 2015, a map tab. Every time you open your browser, you get a new image. Here's another one from the Art Institute of Chicago in 2020. And most recently, an example from State Library of Victoria from 2025. My conclusion from this is that browser tabs allow us to contemplate beauty, and that is in itself a beautiful thing. The next example is that of exploration, guided exploration of an individual object, and here is a lovely example from way back in 2016, exploring an item from the Wellcome collection. Then I looked at games. Here's a lovely game. It's made by Leander, and it's called Exquisite Corpse. It allows you to mix up multiple faces. And finally, I looked at installations. Here's me. I'm pretending to be a man who is pretending to be a Blade Runner.
Answer 224 to 176.
I'm talking to a cardboard model of a computer.
Stop.
And when I talk to it, it's moving the image around.
Stop.
What I conclude from this is that this is very likely to be an evolutionary dead end. I have more general conclusions. They are these. More data is needed, particularly more fun is needed. More funding to fund the effort for the fun is needed. And please do help me to join the data, to improve the data set by joining in and adding your own entries. I thank you.